Hello everyone, welcome to today's tutorial. We will be continuing our background study on Surds, and this is video 3, and we are going to be looking at the addition and subtraction of Surds expressions. I want to watch the previous videos that I've made so that you can have good knowledge and you'll be up to speed with what we have done so far. Before we go on to solve these questions, I'd like to mention something, and that is the concept of similar sort. You recall I said when we were looking at the rules of sort that they are, especially for the addition and subtraction, that you cannot add or subtract sort that have different values, irrational values. Now, are you getting me now? So you cannot do, for instance, you cannot add x and y together. The values for you to be able to perform addition, are you getting now? This cannot happen. For this to happen, for you to be able to perform the addition, they must have similar rational values. That means that the expressions, the numbers in the roots must be the same. Are you getting me now? That is the only condition in which you can either perform addition or subtraction of expression that is in sort. And that's the concept of similar. They must have the same expressions in the rational values must be the same before you can go on to do either an addition or a subtraction of sort, and that's what we want to look at in this particular expression. Now, before you determine that, like I said also, before you can add, you must look at the rational values of each of the expression and look at, are they the same? If they are different, you leave your answer that way. You cannot go further. I get me now. You leave the answer that way. Only values that have the same irrational values are the ones that you can proceed to perform operation on. I get me now. You're going to see how that plays out when we are solving these various questions. So let's go into solving. Now, you can see that from the first one, the irrational values are the same. They are both root 2 and root 2. I get me. So I just simply need to. It simply means that the addition operation will only take place for the values outside of the rational expression. Now, even though obviously this you will see that we can rewrite this as, since they have the same value now, say 3 plus 5 root 2. I guess now root 2. Since they are the same value, I don't need to repeat this rational value there. I just need to write it just once. I guess now. Let me put this just two in brackets. Since they have the same value, I just write it once. I get it now. Then whatever number, if they have the number outside of the expression, we add them together, we subtract them together, depending on what's it called, whatever word signs is attached to our question. In this case, we have the addition, so we are doing 3 plus 5. That's the values of the numbers that we have outside of the rational expression of this figure. So that means at the end of the day, we are going to have 8 root 2. I get it now. Even if you go on to say 2 plus 2, you're going to have 4. And then when you take the square root of, and you don't have to do it that way. I get me now. It's not a necessary process. Like I said, this is addition. I get me now. So you just pick one of these roots. I get me now. And that will become what? You have what? 8 root 2. Is that okay? Now let's move to the second expression. We can see that they have the same rational values to 3. I get it now. So we go on to do the same thing. So 5 minus 7 root 3. So 5 minus 7 is a negative 2. I get me now. So that will be minus 2 root 3. So these ones are very simple because we can look at the what's it called now? The rational values, and they have similar expressions. But when you look at number 3 and number 4, it means that the words do not have the same rational values. Some can just say that, oh, you cannot do anything. But before you conclude that you cannot do anything, you have to simplify, which is what we did in the previous video. You should watch the previous video if you didn't watch it. How to reduce Surds into the basic form. And that's what we're going to do for each of these 3 expressions. We need to reduce them to their basic form. And what we need to do is to find a multiple of these figures. At least one or more of the numbers must be a perfect number, where we should take the perfect square of it. Now let's see. how we can express this number 3 in so let's solve for this number 3. We have so root 32, I can say 16 times 2, yes. So 16 times 2 is an expression for 32. 128, 64 times 2, and for 72 we have 36 times 2. I get me now. Now you can see that both 16, 64 and 36 are figures that we can take their perfect squares. I get me now. So the perfect square for 16 is 4. I get me now. So that will come when you are taking it to come outside. So this will become 4 root 2, right? The square root for 64 is 8, right? 8 root 2. Then the square root of 36 is 6. So it becomes 6 root 2. Now what we have done now is to have a consistent rational values for this expression, which is what we have done here now. We now have a consistent rational value for each of all of these expressions that we have here now. So what I need to do now, okay, is a minus value we have here. So take note of the signs that you have in your question so that you don't get mixed up. I just did now. So that means that we have to put the values outside and perform our operation. So we do the 4 plus 8 minus 6 root 2. Just like I said earlier, root 2. So 4 plus 8 is 12. 12 minus 6 is 6. So that means that the final expression for number 3 is 6 root 2. So that is that about that. So we have seen how we have broken down solving number 3. Now let's do the same thing for number 4. So here we already have this is split already. Obviously the figures are different too, so we need to express them further. So number 4, you can say let's express them all in the expression of root 3. We can pick a root 3 out of all of them. Let's make them multiples of 3. So this is 9 times 3 for minus this is going to be, if we divide this by 3 now, we're going to have 2 and 5. So 25 times 3 is 75. Then plus 5 into 4 times 3. So we can see that all of these figures, we have found a unique figure to multiply them, which is 333. Like what we did here now is 2, 2, 2. I guess now. So usually you find that when you have questions like this, there will usually be a constant figure that you can use to multiply, that you can now isolate as the value of your new irrational expression in your question. Now, so let's remove the values that we can take the square root of here. So here we have 3, so we can take the square root of 9 to give us 3. So this will become 3 times 3 root 3 minus 5 root 3. I guess now plus. So this is going to be 5 times 2 root 3. I get me now. So at the end of the day, we're going to end up with 9 root 3 minus 5 root 3 plus 10 root 3. So if we do a normal operation like I usually do, so we have 9 minus 5 plus 10, which will give us, that's the root 3. So when you do your addition and subtraction, so 9 minus 5 is 4, 4 plus 10 is 14. So now we're going to end up with 14 root 3. So I believe that all of these things that you have done is very explanatory. When you have expressions that do not have similar rational values, you will reduce them to the basic form. I get me now. So that means they are looking for an expression where one of the values will be an irrational expression. Then you can take the square root of the other number that you have in that case. I believe that this video has helped you, that you reinforced your learning, and you have an edge now when you get to your class. So remember to share this with your friends, follow our page, subscribe to our YouTube channel, and I look forward to seeing you in subsequent videos. In the next video, we're going to look at the multiplication of surd expressions, and we're going to do the division in a different video. So watch out for the next video. We're going to be dealing with the multiplication of surd. Thank you.